Good morning. It is January 5th, 7:25 a.m. 2019. Alright, anyway. I had success last night. Had ignition for the first time. I'm going to show you the setup I have here. Alright. So we'll start over here, the power supply. Basically, well, I think I've shown this already once, but down here on the ground, I have my Scariac. Sitting on the Scariac is a gardening pH meter. I thought, oh, I'll use this to see how strong my solution is. Well, of course, you stick it in there and it just maxes out the scale, so I guess it's strong enough. Anyway, this is the microwave oven power supply, which I don't really have going right now because the diodes are just heating up way too fast, so drawing way too much current for those diodes. So I have more on order, but I ordered them from China, so you know, it might be a month or whatever before I see them. So in the meantime, what I've done, because I mean, I don't know, I may not even need this, but I would still like to do some other experiments with some higher voltages. Anyway, right here is what I have powering the cell right now. So let me come over here where I can show you. Basically, here's the cord coming into it. This is just a junction block, so I have, you know, spade terminals coming off, and then these are high pressure sodium transformers, or ballasts is what they're called, and in their original configuration they're actually a step down transformer, but they used they used an igniter, one of these doohickeys, to create a high voltage pulse to start the arc in the high pressure sodium, and then this actually steps down the voltage and regulates the current, so that, you know, the thing just doesn't have a runaway, basically, because as the bulb heats up, the resistance goes down, the current goes up. So these are somehow wound to be current limiting. And then I really don't know how this thing works. I tried getting online and doing a Google search, and I really didn't find very much information about them. So yeah, I guess I'm curious really how they work, because they might be useful, but I don't, till I know how they work, I don't know what to do with them exactly, because in your standard configuration transformer, this isn't necessary. So anyway, what I've done is I've flipped around these so that instead of them being a step down transformer, they're now a step up, but they only step it up to about 250 volts AC. So really it's only like about a doubling of the voltage. So anyway, I have outputs running then into another junction block that then feeds a full rectifier bridge back here. These are 1,000 volt, 3 amp rated diodes. I have them, I got masking tape as an insulator, one layer on this aluminum. It's a CPU heatsink. I don't have the fan. The fan's on there, but I'm not running. It's thermal mass basically. And then I have masking tape again over the diodes leads for insulation, and then the diode body was exposed, and then I put the 2 layers of aluminized tape over that to help conduct the heat and distribute it into the I don't know if you can see that very well. There we go, maybe. So yeah. And then of course, right now I don't have any smoothing caps. That's something that's the next thing I'm going to try before I run it this morning is, because I have on the microwave oven MOT, as they abbreviate it to, MOT, microwave oven transformer. I have a big bank of electrolytics that I was going to use for smoothing the output of this, but what I'm going to do, and I have it all zip tied on here and shit, but I'm going to go ahead and I'm going to cut the zip ties and take it off, and I'm going to hook it up to the output here. So that's what I'm going to use as my DC smoothing. And I'm not sure, I got a whole bunch of these capacitors. They're AC capacitors rated at 280. They were with the high pressure sodiums, and I don't know, they were just across from the high volt output to ground is how they were wired up, and I'm not sure. I don't know. Basically, I was going to go ahead and try it, and like they were wired up, I was just going to do it, I think, just off of here, probably. See if it has any effect on the performance. If there was, each one had one, I'll probably go ahead and wire up in, parallel 4 of them off of here. Because I don't know if I want to run it off the high voltage, because I bought another meter. It's the cheapest meter you can buy. It's like $5. But it says it'll do 1,000 volts. So I tried to read 1,000. Well, I'm pretty sure I'm way under 1,000 volts with this, and yeah, it totally blew it up. So, well, what I did was I switched ranges with it hooked up, and then it stopped working. So I think what it did is it created some sort of inductive spike, and yeah, went way above its rating, and it didn't have any kind of active shunt or whatever, so it just popped it. I mean, big sparks inside of it and everything. Which that's why I bought the $5 one, because I've already blown up all 3 of my other meters that I have here at the house. So yeah. And this one unfortunately did not have a high enough ohm range to check my high voltage probe that I already blew up, to figure out where it blew up and then try to fix it. So I'm gonna have to get my meter from work to check that. I'm not. It's supposedly rated to 1,000 volts too, but I'm scared to hook it up because I need it for work. So I'm probably just going to use it to try to get my high voltage probe working again, and then probably go try to buy, I don't know, I guess I probably could return this, but I kind of feel, well, I can't because I cut the leads off. So I'll have to go buy another one of them, I guess, and then hook it up to my high voltage probe and try it. That way, if it blows again, I only wasted $5 instead of, I think those other, I mean, they were, you know, more probably $20, but that's still, it's $20 that I just, you know, burned up. But anyway. $40, and then I had my son's, he bought, I don't know how much he paid for it, but I also fried it too, so. Anyway, so from the output of the rectifier bridge, this goes up to my other junction block, with the, you know, where I have my big cables hooked up, which are obviously way overkill for what I'm doing. So I will probably, well, yeah, I mean, because once I make my other cell, it's going to be difficult to run that big fat cable down to the center electrode. So yeah, and I'm not pushing that many amps anyway, so I'm gonna use something different. So anyway, I guess so I'm gonna go ahead and try to hook up some capacitors and then try running it again. Because the problem I had, and I don't know, maybe I already, and it might not do it. It only might have been doing it because of the state that the system was in. But last night, at some point, the transformers started making a kind of a strange buzzing noise. It sounded almost like they were arcing internally. So I don't know. Again, yeah, I don't know. I tried unplugging each one, and you know, it still made the noise, so it wasn't isolated to any one transformer. So yeah. Okay, that's enough for now.